Hi, 8th graders. This is Miss Hash, and I've got notes for you today. Pardon me. We're starting a new chapter, Butterflies, Pinwheels, and Wallpaper. This chapter primarily focuses on properties of geometry. And so the first thing that we're going to cover are different types of symmetry and different types of movements on a coordinate plane. So we're going to start today using graph paper to take notes. Graph paper is the best way to do these notes because we've got to organize a coordinate plane and flip some shapes on that plane. So if you don't have graph paper yet, you need to quickly get some from the student center and then return to your seat so that we can take these notes. So the lesson is 1.1, line reflections. Line reflections. There is a example that we're going to come back to over and over again in this video. Think back to elementary school when you made maybe your first Valentine to give to your mom or your grandma or somebody else that you knew. And oftentimes when we're young making Valentines, especially if you're using paint, you would draw something like half of a heart on one side of the paper and then fold that paper in half to transfer the paint onto the other half. We're going to be coming back to that example several times today, so if you haven't had a chance to make one of these Valentines, I'm sorry. They're a lot of fun. Feel free to go home and play with all the paint that you want. Okay, so again, line reflections. The first thing we need to do is take some vocab terms here. And our only one for today is reflectional symmetry. Reflectional symmetry. This is a transformation a geometric transformation in which a figure or shape is flipped over a line. Reflectional symmetry. So just like that Valentine I mentioned, you paint on one half of the paper, you fold it in half, and it gets flipped over onto the other side. When we're using reflectional symmetry, it's important to remember that each flipped point is the same distance away from the line as the original point. Each flipped point is the same distance away from the line as the original point. Meaning, if we're thinking about that elementary school Valentine, when we fold it in half, they're going to be exactly the same distance away from the crease in the middle. Unless for some reason you squeeze too hard and your hands slip, and then you're just left with a sloppy Valentine. I'm sorry. Let's draw an example. We're going to make a 4-quadrant coordinate plane. So I'm going to take quite a bit of space here. So that's 12 boxes tall, a nice even number that I can split in half. And let's go ahead and label our axes. So we've got the y-axis and the x-axis. And notice that I've left some space on the sides because we're gonna actually have to add some notes on the sides. So we are gonna use reflectional symmetry to flip a shape on this grid. The shape we're gonna flip is a square, but it's not a straight up and down square. Thinking back to our Pythagorean theorem unit, we're gonna make a tilted square. So it looks kind of like a diamond. And then when we go ahead and connect those sides, it forms a tilted square. In order for us to name this square, we need to add some labels to the vertices or to the corner points. So I'm gonna label it A, B, C, and D down here. So that's the name of our shape. A, B, C, D is the original shape. It's the OG. Okay. We're gonna start by reflecting A, B, C, D over the x-axis. So we're gonna start with it up here and flip it down into here. So because point D is already on that axis, when we flip it, it's not gonna actually move anywhere. Again, think about that Valentine you made in elementary school. If this was our fold, if this was the crease of the paper, any paint that was stuck in the middle would end up staying in the middle. So D is not gonna go anywhere. But A, B, and C will flip over the line. So I'm actually gonna start with B, 1, 2, 3, 4 boxes. 1, 2, 3, 4 boxes, put a dot. And then connect my dots to show that it's the exact same tilted square that we started with. Now, because it's a different shape and, well, it's the same shape, but it's in a different position, we have to give the points different labels. So we don't want to get confused. I'm not going to assign different letters, but I'm going to add an extra marker to show that they're a little bit different. So instead of just point A, I'm going to label this point A prime. There's a tiny little tick mark in the upper right-hand corner to show that it's prime. B prime, C prime, and this one will be D prime. It's kind of like an exponent, but the prime marker just tells us that this is not the original shape. It's like the original shape, but it's been changed in some way. Now that we've named our shape, we're gonna write down just a note about our shape in this corner. Its name is A prime, B prime, C prime, D prime. And the shape itself was flipped over the x-axis. Okay, so we started with the original shape, flipped it to create a second copy of that shape. And we're gonna do one more reflection before we move on. So we flipped our first shape over the x-axis. I now wanna go back to our original shape and flip it over the y-axis. So think of this as the fold in the paper. We're gonna copy it over. So again, each flipped point is the same distance away from the line as the original point. So if A is the original point and it's 1 box away from the line, then my new point is going to be 1 box on the other side. And all of our other points follow to create the tilted square. Okay. So A, B, C, D was our original shape. A prime, B prime, C prime, D prime was the first copy of our shape. Because this is the second copy, we're going to call each of these points double prime. So this would be A double prime. It's just 2 tick marks instead of 1. B double prime, C double prime, and finally D double prime. The name of this shape is really long. A double prime, B double prime, C double prime, D double prime. So this shape was flipped over the y-axis. We flipped one shape over the x, and we flipped our double prime shape over the y. Now, when we're doing reflections, there are three characteristics that will always stay true. We're going to write those down in this space on our graph paper because I'm saving this remaining space for something else. Reflecting over a line. Some characteristics here. First thing is it keeps the same shape. Just because I took an original shape and flipped it into a new position doesn't change anything about the actual shape. My original square didn't magically turn into a rectangle or an octagon or a pentagon. It stayed a square, it stayed tilted, and it stayed the same shape. Reflecting over a line also keeps the same measurement. So if I had a ruler handy, which right now I don't, and I measured the sides of our original shape, flipping the shape over the x or y axis did not change the length of the sides, so the measurements stayed the same. And finally, reflecting over a line keeps the same angles. So like I said earlier, this square with 90-degree angles didn't just magically become a pentagon with 120-degree angles. It stayed a square, everything stayed 90, as it was successfully reflected over the x and the y axis. The last topic we're going to add to our notes to fill in a little bit of this space is lines of symmetry. Symmetry has two M's. That is not a spelling error. Lines of symmetry. So again, back to that Valentine example. Folding your paper in half creates a line of symmetry because one half of the heart would be identical to the other half if that paint squishes over to the other side. So lines of symmetry are the lines that a shape flips over. So in our example, it flipped over the x-axis and it flipped over the y. Or it could be a line that cuts something in half. A line that cuts something in half. So we're going to do one quick example here, and then we'll wrap up. All right. So to do this example, we're going to draw a block letter H. And I didn't pick this letter because it's the first letter in my name. It's also the last letter in my name. I picked H because it works really well for the example and it shows lines of symmetry. So the letter H has two lines of symmetry. It has two lines that cut it in half. One line of symmetry runs from top to bottom, dividing it in half, so the left would look exactly as the right. And its second line of symmetry goes through the middle of the shape. So if we were to fold the shape in half, the top would look identical to the bottom. There are other shapes and other examples out there that have way more lines of symmetry. Some shapes have infinite lines of symmetry. So it's important to kind of keep an eye out for those things, keep an eye out for what makes something symmetrical, and try to maximize those lines. Okay, there is homework time built into class today. So as soon as you get a homework page, put your name on it, put the date on it, and go ahead and get started. Leave your notebook out so that you can come back to these notes for reference just in case you get stuck. I'll see you guys on Friday. Have a great afternoon.